Welcome to another One with Math video. Today's video, how to perform partial fraction decomposition with repeated linear factors. Take this example, 3x squared minus 17x plus 25 all over x plus 1 times x minus 2 squared. If we take a look at the x plus 1, this is a linear factor. So we're going to have a fraction with a denominator of x plus 1. Then we look at the x minus 2 squared, we notice this is a repeated linear factor. Particularly, this x minus 2 has been repeated 2 times, meaning we're going to have 2 fractions. One fraction is going to have the denominator of x minus 2 to the power 1, where the other fraction is going to have the denominator of x minus 2 to the power 2. We don't know the numerators for each of these fractions, so let's call it a, b, and c. Now let's multiply both sides by the original denominator, x plus 1 times x minus 2 squared. For the left side of the equal sign, we notice the x plus 1 will cancel, as well as the x minus 2 squared, leaving 3x squared minus 17x plus 25. On the right side of the equal sign, the one with the a term, we notice the x plus 1 will cancel, leaving a times x minus 2 quantity squared. And for the one with the b term, we notice there are 2 copies of x minus 2 in the numerator and 1 copy of x minus 2 in the denominator. So one of the x minus 2 will cancel, leaving b times x plus 1 times x minus 2. And for the fraction with the c term, the x minus 2 squared in the numerator and denominator will cancel, leaving c times x plus 1. And now we'll choose any x values we want. So we take a look at the x minus 2. If we let x equals 2 and substitute it all in, so we'll substitute into this equation. We'll simplify this. We get 12 minus 34 plus 25 is equal to 0 plus 0 plus c times 3. Simplify this. We'll get 3 equals 3c, and 1 is equal to c. So we solve for c. Now, since we already looked at the x minus 2, let's look at the x plus 1. So if we let x equals negative 1 this time, and substitute this into this equation, this is what we get, which will simplify to 3 plus 17 plus 25 is equal to a times negative 3 squared plus 0 plus 0. Simplify this, we get 45 is equal to 9a, or a is equal to 5. So we solve for a. And now we look, there's no more factors to look at to pick x values. So if there's no more, choose the easiest x values you can think of, which will be let x equals 0. So we'll substitute x equals 0 in. We'll simplify, and we get 25 is equal to a times negative 2 quantity squared plus b times 1 times negative 2 plus c times 1, which will simplify to 25 equals to 4a minus 2b plus c. But here we have 3 variables. Luckily for us, we already solved for c, which is 1, and a, which is 5. So we'll substitute this in, and then we'll simplify. So we get 4 is equal to negative 2b, or b is equal to negative 2. So we solve for a, b, and c. Now we just need to write the solution. So we have 3x squared minus 17x plus 25 over x plus 1 times x minus 2 squared. So this is going to equal to a over x plus 1 plus b over x minus 2 plus c over x minus 2 squared, where a is 5, b is negative 2, and c is 1. So this is how you perform partial fraction decomposition with repeated linear factors. Here's our second example. We have 5x cubed minus 23x squared plus 40x minus 32 divided by x minus 3 times x minus 1 cubed. So in the denominator, we have an x minus 3, a linear factor. So we're going to have a fraction with the denominator of x minus 3. And then we have x minus 1 cubed. It is a repeated linear factors. And this x minus 1 has been repeated 3 times. So we're going to have 3 fractions. One fraction with the denominator of x minus 1 to the power 1. Another fraction with the denominator of x minus 1 to the power 2. And another fraction with the denominator of x minus 1 to the power of 3. We don't know the numerators, so let's call it a, b, c, and d. Now, let's get rid of the denominators. Let's multiply everything by the original denominator, x minus 3 times x minus 1 cubed. For the left side of the equal signs, we'll notice x minus 3 and x minus 1 cubed will all cancel out, leaving 5x cubed minus 23x squared plus 40x minus 32. Right side of the equal signs are going to part with the a term, well, a fraction. X minus 3 will cancel, leaving a times x minus 1 cubed. For the fraction with the b term, we notice that there are 3 copies of x minus 1 in the numerator and 1 copy of x minus 1 in the denominator, meaning the numerator has 2 more copies of x minus 1. So we get b times x minus 3 times x minus 1 squared. For the fraction with the c terms, there are 3 copies of x minus 1 in the numerator, 2 copies of x minus 1 in the denominator. So they will cancel out, leaving x minus 1 in the numerator. So we have c times x minus 3 times x minus 1. And finally, for the one fraction with the d term, the x minus 1 cubed is both in the numerator and denominator, so they cancel out, leaving d times x minus 3. Now, if we look at the x minus 1 and let x equals 1, we'll substitute in. This time we'll do it a little bit faster. Substitute in and simplify. We will get 5 minus 23 plus 40 minus 32. That is equal to 0 plus 0 plus 0 plus negative 2d. And then simplify, we get negative 10 is equal to negative 2d, or d equals 5. So we solve for d. Now, let's look at the x minus 3 factor, and let's let x equals 3 this time. We'll substitute in, and we'll simplify as we go. 5 times 3 cubed is going to be 135. Negative 23 times 3 squared, negative 207. 40 times 3 is 120, and negative 32 is negative 32. That is equal to 8a plus 0 plus 0 plus 0. Simplify this, we get 16 is equal to 8a, or a is equal to 2. So we solve for a. Now there's no more factors, so we can choose x values. So let's choose another x value that is simple to use, such as x equals 0. Substitute this in and simplify. We get negative 32 is equal to a times negative 1 cubed plus negative 3 times negative 1 quantity square plus c times negative 3 times negative 1 plus d times negative 3. Simplify this, we get negative 32 is equal to negative a minus 3b plus 3c minus 3d. Since we already solved for a and d, we'll substitute those in. A was 2 and d was 5. Substitute in, simplify, and then add on both sides. We get negative 15 is equal to negative 3b plus 3c. Since everything is divisible by negative 3, let's divide by negative 3. So we get 5 is equal to b minus c. So here we have b and c left, and we can't really do anything else with it yet. So we'll need more space, so we'll move on to the next page. Alright, here's all the information that we found on the previous page for some convenience. Now, we'll need to pick some x values. So let's choose the next value. Let's choose x equals negative 1. You can choose any x value that you want. If you want x equals 2, you can use that. X equals 4, x equals 5. Typically, I try to choose x values that is close to 0 to make the number smaller. Alright, we'll substitute x equals negative 1 in and substitute in. And then we're going to simplify. Once we simplify, we get negative 100 is equal to negative 8a minus 16b plus 8c minus 4d. We'll substitute in the a and d that we found already. So a was 2 and d was 5. Simplify this, we get negative 100 is equal to negative 16 minus 16b plus 8c minus 20. Then we'll add 16 and 20 on both sides, and we get negative 64 is equal to negative 16b plus 8c. Since everything is divisible by 8, let's divide by 8 to make the number smaller, and we get negative 8 is equal to negative 2b plus c. So here we're left with b and c. But then we recalled earlier that we solved that 5 was equal to b minus c. So we put them both together. We'll have negative 8 equals to negative 2b plus c, and 5 is equals to b minus c. We have a system of 2 equations with 2 unknowns. Since we have a positive c and a negative c, we can just add vertically and it will eliminate the c's. So we'll do that. We'll add vertically, and we get negative 3 equals to negative b, or b is 3. Then we'll substitute in the second equation of 5 equals to b minus c, where b is 3. Solve this, we get 2 equals negative c, or c is negative 2. Last step is to write the partial fraction. So this fraction is going to equal to a over x minus 3 plus b over x minus 1 plus c over x minus 1 squared plus d over x minus 1 cubed, where a is 2, b is 3, c is negative 2, and d is 5. So this is how you will solve if you have x minus 1 cubed, 3 repeated linears. And for our final example, we have 8x cubed minus 5x squared plus 2x plus 7 divided by x plus 1 squared times x minus 1 squared. For the denominator of x plus 1 squared, this is a repeat linear factor. It's been repeated 2 times, so we're going to have 2 fractions. One fraction with the denominator of x plus 1, another fraction with the denominator of x plus 1 squared. Now for the x minus 1 squared, this is also a repeat linear factor, and it's been repeated 2 times. So we're going to have 2 fractions for this one. One's going to have the denominator of x minus 1, another with the denominator of x minus 1 squared. Again, since we don't know the numerator, we'll call it a, b, c, and d. Let's multiply both sides by the original denominator of x plus 1 squared times x minus 1 squared. On left side equal signs, we'll see what cancels, and we're left with 8x cubed minus 5x squared plus 2x plus 7. For the fraction with the a term, one of the x plus 1 in the numerator and one of the x plus 1 in the denominator will cancel, leaving a times x plus 1 times x minus 1 squared. For the b terms, both the x plus 1 in the numerator and x plus 1 in the denominator will cancel, giving us b times x minus 1 squared. For the c terms, one of the x minus 1 in the numerator, one of the x minus 1 in the denominator will cancel, leaving us c times x plus 1 squared times x minus 1. And for the d term, x minus 1 squared in the numerator and x minus 1 squared in the denominator will cancel, so leaving us d times x plus 1 squared. Now we look at the x plus 1. If we choose x to be negative 1, substitute in and simplify. This is what we get. Negative 8 minus 5 minus 2 plus 7 is equal to 0 plus 4b plus 0 plus 0. Simplify, we get negative 8 equals 4b, or b is negative 2. Now, if we look at the x minus 1 factor and let x equals 1 this time and substitute in and simplify, we get this. 8 minus 5 plus 2 plus 7 equals to 0 plus 0 plus 0 plus 4d. Simplify this, we get 12 equals 4d, or d is equal to 3. Alright, since we have no more factors to choose, we're going to choose any x values you want. Let's choose x equals 0 since we haven't used it yet. With x equals 0, substitute in, simplify, we get 7 equals a times 1 plus b times 1 plus c times 1 times negative 1 plus d times 1. Simplify this, we get 7 equals a plus b minus c plus d. Use the b equals negative 2 and d equals 3 that we found earlier, and then simplify, and we'll get 6 equals a minus c. Now we need more space, move on to the next page. Alright, here's everything that we found on the previous page, so for some convenience. Now, if we let x equals 2, we'll substitute in and simplify. This will simplify down to 55 equals to 3a plus b plus 9c plus 9d. We'll use b equals negative 2 and d equals 3 that we found earlier. Substitute this in and simplify. Simplify some more and then add or subtract on both sides. We get 30 equals 3a plus 9c. Since everything is divisible by 3, let's divide by 3. So we get 10 equals a plus 3c. Now if we use this 10 equals a plus 3c and combine it with the 6 equals a minus c that we found earlier, we could subtract vertically to eliminate the a. Subtraction can also be a little hard to deal with, so let's multiply the second equation by negative 1. And so we get negative 6 equals to negative a plus c. And now let's add vertically. So we get 4 is equal to 4c, or c is equal to 1. Substitute into the second equation, which was 6 equals to a minus c. So, and substitute in c equals 1. We will solve this and we get 7 is equal to a. So we solve for a. Last step is to write the partial fraction. So here's our fraction. If we write the partial fraction, we have a over x plus 1 plus b over x plus 1 squared plus c over x minus 1 plus d over x minus 1 squared, where a was 7, b was negative 2, c was 1, and d was 3. So here's a partial fraction decomposition with multiple repeated linear factors. Comment, like, and subscribe. Thank you. Bye-bye.